Cœur whisky, 3, 2, 1, top.
100, 50, 40, 30.
Pour moi, je suis prêt à démarrer les moteurs.
Tu vas démarrer en avant.
Allons-y pour les moteurs.
Alors pour le 1.
C'est OK pour le 1.
Welcome to Airbus.
Welcome to the Airbus podcast, We Make It Fly. In this series, we are focusing on all that matters in space, defense and security. I'm Matthias Pikili, and in this episode, I'm talking to Albert Falke, Program and Project Manager for Asteroid Deflection and Planetary Defense. Hello, Albert. Welcome.
Hi, Matthias. Thanks for having me here today.
If I look to your business card, it sounds you're doing screenplays for Hollywood movies like Armageddon or Deep Impact, where humans are sent out into space to destroy asteroids. Are you doing movies or is it a real threat?
Well, no, we are not doing movies. Although the threat we are dealing with is quite similar as the one addressed in blockbusters like Deep Impact or Armageddon. So we are really preparing to protect the planet against asteroids which might impact the Earth's surface. And that's a very interesting and fascinating topic because these are engineering activities and tasks which have never been tackled and done before.
So you are not Bruce Willis of Airbus, but still Albert Falke doing space systems.
Indeed, yes. Bruce Willis would be too much to say, but it's still interesting and it's motivating.
But there are still some popular people involved in asteroid deflection. Once a year, people celebrate the Asteroid Day and commemorates the asteroid impact in Siberia, known as the Tunguska event. And Asteroid Day organization was co-founded by popular people like Dr. Brian May, people know from the rock group Queen, and others like the Apollo astronaut Rusty Schweickart. So a lot of people are working on this subject. Where do you fit in?
Yeah, it's a common activity. Asteroid Day, which has been founded in the following years after the Chelyabinsk event and is now celebrated each year. This is, let's say, a public awareness activity, basically. And they are supporting and fluting all the boats which are preparing in order to help and to improve any deflection activities which might become applicable in the future. So our side, our Airbus activities are leading in order to prepare and design concrete deflection mission. This means a space mission, a spacecraft or several spacecraft which are then able to send out to an asteroid and divert it from its threatening trajectory into the Earth atmosphere. And that's how we fit into this scenario. We have very good contacts to all the asteroids community and are involved in several projects over the years, from technology development over space mission design concept developments, and finally also to short scenario or short warning scenario deflection methods concepts.
So that means you're really working on solution to avoid such damage impacts. They have been caused in Siberia, which was damage of more than 2,000 square kilometers and destroying 80 million trees. So this sounds heavy, but this was a rare populated area. But what will happen when it comes to a more populated area? Is that what you want to avoid?
Indeed. Yeah. Luckily, the Tunguska event in 1908 appeared in a rare populated area, but it could also happen that the same-sized asteroid would explode over a metropolitan region, let's call it Berlin or New York or whatever, and then millions of people would have been affected and potentially killed due to this activity. And in order to prevent such events, which have catastrophe-like consequences, we are going to prepare deflection missions which would help in such a scenario.
Do you have any clue how many we can expect being so dangerous, or do you have any idea about time? When can it happen? What is the scenario or the possibility you are looking on?
The scientists are working on this in manifold directions. The first objective is to discover all the objects. They expect, and this is all about statistics, they expect about 100,000 of objects, let's say, in the area which come closer to Earth over the years. And up to now, we have only discovered about 20% of them. Most of the already discovered ones are the large and big ones, which are easy to observe from telescopes. But there are thousands and also millions of other ones which are way smaller, but still have enough energy and enough mass to destroy certain areas like a metropolitan region or a smaller country. And this is the objective what we really want to avoid.
I look to the usual realization time of a satellite or a spacecraft or a rocket. Takes years. If you find some, as you say, only 20% are known, becoming a threat, you don't have the time to do so. What's the basic idea to get it out of the way in time?
The most important thing is to discover them as early as possible. And all of the discovered ones, the orbit information is known and their orbits are predicted over the next 100 or up to 200 years. And if there is an intersection between those forecasted trajectories and the Earth orbit, then a certain impact threat is calculated. And based on this information, right now there are a couple of objects which are on a risk list, but none of them requires immediate activity from humankind. From the known object, there is no real threat which is existing in the moment. But based on the discoveries, there are 3 to 10 new discoveries each day. And those objects are then observed for several times in the following days, which helps to determine their orbits even better. And this, in most cases, brings down any existing impact risk, which is the most realistic and most likely case. But if at some point of time, one of those new discovered objects ends up in a higher impact threat, then our chances to deflect them might be really required. So for instance, if we can calculate an impact risk in 20 years, then we have several options to deflect them, because then we have time to develop, to build, and to launch a deflection or a mitigation mission. For instance, there is the kinetic deflection method. This is something like a usual satellite which is equipped with a specific targeting mechanism which helps to guide the satellite with a very high velocity into the asteroid. And by this push, the trajectory of the asteroid is changed very, very small. You can compare it like a mosquito on the windshield of a car. It's really not much. But this small effect accumulates over time, so that when the asteroid passes the Earth's orbit, the Earth is already away.
Which kind of information, besides the trajectory, you have in advance to calculate the mass and the consistence of the asteroid?
Yeah, that's a crucial point. A lot of scientists are working in this context. The scientists did a lot of modeling activities based on the information they obtain from the telescopes. And last but not least, in the recent time, there were some asteroid missions which helped to gather way better information from the asteroids itself. So there's the Hayabusa 1 and 2 mission from the Japanese JAXA. There are also OSIRIS-REx from NASA. And there are a lot of other flyby missions of satellites and spacecrafts to asteroids and also comets, which help to specify and obtain more detailed information of the asteroid structure and how an asteroid would perhaps respond to a deflection attempt. And based on all of those information, we can constrain the energy which we should not exceed in the order to not disrupt the asteroid itself. So we know that some of the asteroids are very loosely bound, so they are more or less like a bunch of gravel tied together from the very weak, say, gravity mechanisms over there. And also in this case, such a kinetic impact method would not exceed the energy to disrupt it. And that's one of the most important points, which ensures that also the kinetic impactor method is a safe one, next also to other options, like a very high energy explosion close to the object, which could be done by hydrogen bombs or similar devices.
So let's go through a specific scenario. If you have an asteroid coming into Earth, possibly on an impact course, so what are the concrete scenarios which have to start on Earth.
Even in that case, if we have a very short warning time of 3 or 5 years, we already need to have a lot of deflection hardware prepared in our assembly and integration facilities. Because when we launch a satellite, it will travel through the space up to half a year or 1 year and then impact the asteroid in order to deflect it. And after this impact, we need some time, this is the order of months or even years, to let the deflection impulse work and accumulate over time so that the asteroid misses the Earth then. So, and keeping this in mind, we need 1 or 2 years after the launch of the satellite to let the asteroid pass along Earth instead of impacting it. And therefore, the prerequisites or the timeline from the asteroid discovery up to the deflection mission launch is really, really short. What we are looking for right now is only 6 months. And you might imagine that we cannot build and even not develop, build, and then launch a spacecraft in such a short time frame. Building a spacecraft is a larger effort and requires more than a couple of years usually. And therefore, we more or less need to have this one already prepared in the assembly and integration facilities and readily tested to be launched in a very short time scale of just a few months.
Who will fund such a mission?
Because deflecting an asteroid is a global effort, we do not need only one mission. Every space agency which is able to launch and operate such a mission is asked to support and contribute to this common activity. In that case, we are really sure that at least a few of those missions will succeed and provide sufficient deflection energy to avoid an asteroid impact.
So you say asteroid threat, it's not a question, it's only a question of time.
Yes, that's what I say. It will take place. It's just, as you said, it's a matter of time. We may have a couple of years or decades until the next one may impact, but it may also happen already tomorrow. We don't know yet.
So as you're working with Airbus and working on such projects, can you give us a glimpse where we stand today?
Yes, of course. We are working on this since more than 10 years already, but there's still a lot of things to do. The activities which we have done in the past we have been focused on pre-designing and developing a scenario and a concept how such deflection or deflection demonstration missions could be realized. The last project where we are working on is called FastKD. This is looking for a very short warning scenario deflection approach. And this is where we realized that we need to have a deflection spacecraft already prepared. Most of the hardware must be procured and already available and readily tested for launch. And this is one of the most important things. But all the work that is currently done is more or less paperwork. And there's a lot of hardware work which still needs to be continued and further developed. What we have done also in parallel is, I can say, it's a pre-development of the targeting technology. Pre-development in terms of hardware test facilities and software coding and verification. This all looks quite good and the performance is as requested. And we would be able to further develop this and put it on a spacecraft.
So do you have any assumption or a personal opinion when you get off from the paper to, so to speak, to the workbench?
This is not an engineering question. Technically, we could do this tomorrow. There's nothing which stops us. It's just that we need to get proper funding from the spacefaring agencies in order to get ready, to get prepared and increase our deflection capabilities over that deflection capability which the dinosaurs had. So they had no space program 65 million years ago. We have one, but we are not yet there. There's still a couple of years to go and a lot of work to be done.
Thanks, Albert, for talking to you.
Thanks, Matthias.
That concludes this edition of We Make It Fly. If you have enjoyed this episode, don't forget to subscribe us and rate us wherever you get your podcast. You can follow us on all social media and use the hashtag We Make It Fly to get in touch. We would appreciate your feedback. Thanks for listening.